An object older than Earth, traveling faster than any comet near Jupiter, entered our solar system and then grew a tail pointing toward the Sun. This is 3I-ATLAS, the strangest interstellar visitor we've ever seen. Welcome back to Comic Affairs. Today we're diving into the story of 3I-ATLAS, the newest confirmed interstellar comet entered to our solar system. Question is, where it came from and why it's so unusual. On July 1, 2025, NASA's ATLAS survey telescope spotted a faint new object drifting across the sky. At first glance, it looked like an ordinary asteroid, nothing special. But when astronomers started calculating its motion, its speed was quite higher than other planets orbiting in our solar system. Usually, objects in our solar system, planets or asteroids, orbit the Sun with a simple rule: the closer to the Sun, faster the orbital speed. For example, Mars orbits Sun at roughly 24.1 km per second, Earth at about 29.8 km per second, Venus around 35 km per second, and Mercury at 47.9 km per second. As Jupiter is much farther from the Sun and orbits with an average speed of about 13.1 km per second, which is slower than other planets. But when 3I-ATLAS was located near Jupiter, its speed was recorded 58 km per second, which was unusual. This velocity was proof that it was not part of our solar system, but came from another star system, interstellar space. That was the point at which NASA gave it the special designation of an interstellar object and named it 3I-ATLAS, because the network that discovered it is ATLAS, I for interstellar, and because it's the third known interstellar object, hence the 3 in the name. When its identity was determined, scientists traced its older sightings. They found that the object had been seen 2 months earlier in May 2025. When astronomers traced its orbit backward, they found it followed a hyperbolic path, which means it wasn't bound to revolve around the Sun. It was simply passing through. Its journey pointed toward the Milky Way's thick disk, a vast and ancient region above and below the galaxy's thin spiral plane. Scientists estimate 3I-ATLAS to be about 760 million years old, making it far older than Earth. Although the exact star system it came from remains unknown, but it has likely been traveling through the galaxy for over 100 million years, and in all that time, it never passed as close to any star as it did to Sun. When 3I-ATLAS approached our solar system, it stayed cold and invisible. But around 500 astronomical unit near Jupiter's orbit, it suddenly formed a coma, which is much earlier activity than normal comets. This happened because it contains carbon dioxide ice, which begins to sublimate with even a small amount of heat. After passing Jupiter, it crossed several major planetary orbits and, on October 3, 2025, it moved across Mars's orbit, where distant images were captured by Martian probes. 3I-ATLAS continued inward and reached its perihelion at about 1.4 astronomical unit, its closest point to the Sun. When sunlight struck its coma, it displayed negative polarization instead of the usual positive polarization seen in normal comets. In fact, 3I-ATLAS showed the most extreme negative polarization ever recorded for any known object. Its tail was backwards. When it entered our solar system, pointed toward the Sun instead of away, something completely counterintuitive, like dust being pushed toward a fan instead of blown away. As it moved closer to Sun, its tail eventually flipped back to the normal direction. From Earth, 3I-ATLAS wasn't observable because it was behind the Sun. Now 3I-ATLAS is on its way out, accelerating back into interstellar space. It will pass safely through Earth's neighborhood in December 2025, giving us a chance to see how solar heating changed its structure. And on March 16, 2026, it will make a final close pass by Jupiter and will disappear for forever. 3I-ATLAS is a reminder of how immense and dynamic our universe truly is. Its strange behavior, its speed, composition, polarization, and tail challenges our understanding of comet physics and the processes that shape planetary systems far beyond our own. If you enjoyed video, make sure to like, subscribe, and stay tuned for more interesting topics.